Let's start. Most commonly used method for RCC structure, that is limit state method. Limit states are the acceptable limits for the safety and serviceability requirements of the structure before failure occurs. The design of structures by this method will thus ensure that they will not reach limit state and will not become unfit for the use for which they are indeed. Principle of limit state method. Limit state should ensure that the structure will be safe as regards the various limit state conditions in its expected period of existence. Limit state method is based on the concept of safety at ultimate load and serviceability at working load. The two important limit states to be considered in design are limit state of collapse and limit state of serviceability. Limit state of collapse deals with strength and stability of the structure under maximum design load. The divisions of loads, the flexure, we may find out the conditions from clause number 38 of IS 456-2000. For compression, clause number 39. For shear, clause number 40. For torsion, clause number 41. And for tension, I forgot to write this. Sometime later we may discuss the clause number of tension. Limit state of serviceability deals with deflection and cracking under service load, durability under working environment, stability, fire resistant, etc. Now, for durability, we have to follow clause number 8 of IS 456-2000. For overall stability, clause number 20. For fire resistance, clause number 21. For deflection, clause number 42. And for cracking, clause number 43 of IS 456-2000. So, let's check the strain diagram and stress block for singly reinforced member in bending or flexure in limit state method as per codal provision, obviously. In figure 7a, you can see a cross section of a rectangular beam. The dotted line at the center is the neutral axis. From top fiber to neutral axis, the depth of neutral axis is denoted as x suffix u in limit state method. Width of the beam is denoted by small b, and effective depth, that means top fiber to center of the reinforcement, is effective d, denoted by small d. In figure 7b, you can see the strain diagram, and the upper limit is 0.0035. How it comes, we will see later from IS code. Figure 7c, this is the stressed block with partial safety factor. The value of top fiber is 0.45 FCK and at bottom 0.87 FY. And in figure 7D, that is also stress block, comes from obviously from IS 456-2000, clause number 38. But before go to clause number 38, I want to explain you what is FCK and what is FY. FCK is characteristic compressive strength of concrete. For example, for M20 grade of concrete, FCK is 20 FPa, and Fy is characteristic yield strength of steel. For an example, for Fe 415 steel, Fy is 415 MPa. Now let's check clause number 38. Before starting to understand the assumptions of clause number 38, let's take a look at table number 18 of IS 456/2000 for the values of factor of safety. In left column there is the load combination like dead load, live load, dead load, wind load, dead load, live load and wind load, and there in second column the partial safety values of partial safety factors for limit state of collapse, and at extreme right column values of factor of safety for limit state of serviceability. Let's discuss limit state of collapse for flexure. Now, clause number 38.1, the assumptions. Design for the limit state of collapse in flexure shall be based on the assumptions given below. The first assumption is plane section normal to the axis remain plane after bending. Next, assumption B, the maximum strain in concrete at the outermost compression fiber is taken as 0.0035 in bending. Now, let's check the diagram you see earlier. In diagram, now figure 7.b, the topmost, that's my outermost fiber, it is already written as 0.0035. So the value is taken from this assumption. Okay. Assumption C, the relationship between compressive stress distribution in concrete and the strain in concrete may be assumed to be rectangle, trapezoid, parabola or any other shape which results in prediction of strength in substantial agreement with the result of test. An acceptable stress strain curve is given in figure number 21. We will go to figure number 21, but before that let's read it out first to better understand the figure and remember it. Okay, for design purpose, the compressive strength of concrete in the structure shall be assumed to be 0.67 times the characteristic strength, and the partial safety factor gamma m, that is equal to 1.5, shall be applied in the addition to this. So let's go to figure number 21. It is written that with characteristic strength we have to apply 0.67, and after that we have to apply the partial safety factor, that is 1.5. So go to the figure. So stress is in y-axis and strain is in x-axis. There is three curves. There is the maximum limit 0.0035 and minimum limit 0.002. Okay. First of all, FCK have to multiply it with 0.67. See the second line from top. It is already multiplied by 0.67, and then apply gamma m. So 0.67 now third line curve from top, 0.67 FCK by gamma m. We know the value of gamma m as per the code is 1.5. So if you calculate that 0.67 by 1.5, that will be equal to 0.45, which you can see in figure 7c and 7d also. So the value of that figure comes from figure number 21 of IS 456/2000. And let's check, let's discuss the another assumptions. So there is a note, the area of stress block in figure 7d and c. You have already noticed that there is the two stress blocks. So area of the stress block is 0.36 FCK XU, and depth of center of compressive force is 0.42 XU. Let's see the figure. So this area is 0.36 FCK XU, and from top fiber the distance is 0.42 XU. Okay, so this is clear. Now, the next assumption, the tensile strength of concrete is ignored. Note that the tensile strength of concrete in case of RCC structure which we will design with limit state method, in that case the tensile strength of the concrete is ignored. Very important point. Okay. The next point is the stress in the reinforcement are derived from representative stress strain curve for the type of steel used. Typical curves are given in figure 23. For design purpose, the partial safety factor gamma m, that is equals to 1.15, shall be applied. Let's go to figure number 23. You can see in figure number 23, partial safety factor gamma m, that is 1.15, is applied. So now the value is, if you calculate 1 by 1.15, the value will be 0.87, as you see in figure 7.c. The value is 0.87 Fy. So this is clear. The diagram is from IS 456 2000, and all values are taken as per the assumptions of the code of the clause. That's all for this lecture. Thank you.